Here's what 10 degrees looks like midwinter. When temps hit 10 degrees and you got exposed pipe, do you need a drip or a stream? So today we're going to end that debate. The setup is simple here. We've got a coffee mug on a digital scale and we're measuring in grams. We use my iPad as the timer and run for 3 minutes. That way we can track it exactly. On your mark, get set, go. Timer starts, we start the faucet. That consistent drip really accumulates. So about the 1 minute mark, we're at 32 grams a minute drip rate. And so you multiply that by 60, we're at somewhere between 1,800 and 1,900 grams an hour. That's just under 2 liters an hour. That's kind of a practical guide for a reasonable drip rate for our situation, which would be, let's just say it's an 8-foot of pipe that is exposed to really cold temperatures. Now, a typical 8-foot run of 1/2-inch copper pipe holds about 367 grams of liquid. That's a 12-ounce soda can. Not a lot of water inside that length of pipe. With our drip at 2 liters an hour, we're replacing all that water in the entire section once every 10 or 11 minutes. Motion keeps that warmer 50-degree inlet water flowing through the pipe, offsetting the heat loss from the 10-degree air all around the pipe. So it does it quicker than ice can form. The temperature of the water coming out of the ground is somewhere usually between 40 and 50 degrees. Pretty much most of the guides out there agree that for a short, exposed run of pipe like this, it's in still air, there's no crazy wind to cool it faster. A steady drip of around 2 liters per hour and reasonably effective. But what if your exposed section is longer than 8 feet? Or what if you don't know how long the length actually is? Or maybe it runs all the way under your house. What if the temperature is colder than 10 degrees? Maybe you just want overkill protection. Well, you can crank it up. Here's a faster flow. We got this coming out about 150 grams a minute. That's 9,000 grams an hour or 2.5 gallons an hour. Notice how the stream coming out of the faucet breaks apart into droplets at the bottom. That's a visual way to eyeball a higher flow rate without having to measure it on a scale like we're doing. Just aim for a thin, steady stream at its start that gets disrupted into drops before it hits the bottom. That's your max safety margin when conditions are tougher. Ultimately, your setup is going to be unique. So there's no one answer for every single situation. Do you have a short exposed run? A practical guide is 2 liters per hour drip rate. If you have a longer pipe or you just have a zero risk mindset, then use the overkill method. You know the math, you've seen the visuals. Ultimately, you have to be the judge. Protect the pipes the smartest way for your situation this winter. Stay thawed. See you next time.